Okay.
Hello, hello. It's a weekly SIG Node meeting. Welcome, everybody. Oh, date. It's August 8, 2023. Today, we only have one topic on agenda, and Lin Guan will be presenting. Take it over.
Okay. So share. Oh, sorry. I think I'm not able to share the document. Maybe I can just
Let me know if you need my help. I can present.
Yeah, can you help me share that?
Yep.
Because I think I need to quit my Zoom if I open. There is some permission issues. Okay.
Can you see my screen now?
Yeah, cool. Thank you. So yeah, I think this is the continued topic of the meeting of July 18th. So we actually broke down all the problem into 4 of them. So here, yeah, this is the detailed document. So maybe I will briefly talk about each of them, and then you guys can comment more if you have more questions. So the first one is the new static policy for CPU manager. So we know CPU manager has some static policy, and we add actually one more static policy options. It's called a spread physical CPU preferred. So the problem is that in our embeddings, we have a database team, and we actually found an performance gain if we spread the DB container to actually different physical cores instead of like the same hyperthread in the same physical core. So you guys can look at maybe the picture. Can you scroll down? Yeah, so here, if you compare these 2 different CPU sorting image, then you can see the difference. So the first one is like this, the CPU ordering is they will sort according to the virtual cores. Maybe the hyperthread in the same physical cores. And the second one is like we sort the CPU cores according to different physical cores. So we only add one physical, one policy options. So you can just turn it on. So by default, it's not on. So unless you just choose this static policy option. So it's one of the static policy options of CPU manager. So yeah, and also we did some experiments, and you can see the appendix for the detailed experiments to see why this CPU static policy option is better. Yeah, here I think I will not talk about the details of the experiments, so you guys can take a look. So
Sasha left a comment in a document. Sasha, do you want to voice it out?
Yeah.
You mean about which policy?
Yeah.
I think I agree with Francesco what he already put in the same meeting notes. What this looks like just an option to existing static policy. So like the selection which CPU core is just part of algorithm what CPU manager static policy has.
Right.
I don't think we need a special policy for it.
Oh yeah, so right. I think it should be one static policy option. So it's not a new static policy. Maybe I should yeah. I will edit the document later.
Yeah, Francesco also commented on something else.
Right. Yeah, I can briefly talk about it. So the time we invent this policy, it doesn't have the cross NUMA in community yet. And after we evaluate the new policy, we notice there's like a slight difference because the distributed CPU cross NUMA is mainly focused on putting like a hyperthread across the NUMA, and our policies treat NUMA as a kind of like a secondary preferred criterion to cross or not. So it has to cross. It try to firstly cross the physical CPUs in the same NUMA node, and only if there's no like available physical CPUs, then it tries to cross the NUMA. So that the detailed strategy is a little bit different compared to the new edit like across NUMA. I think it's 125. I think, yeah, that's the difference.
Well, here we have actually two different problems. So selecting spreading across physical cores versus like multiple threads on the same core, it's part of a static policy. So like you can look at the option existing one, prefer like full CPU as an example. So like what you're looking for is exactly the opposite what Swati did some time ago for that. But treating NUMA as a secondary thingy, well, it's more a bigger problem because it's not only CPU manager, it's the whole logic of topology manager.
Yeah, I think the first thing, it is true. That's totally different direction compared to the full like the PCPU's only solution, because we do see the noisy neighbor problems in our use case. That's the reason we like to distribute them in different like physical cores. That's only for, I think, we do see the performance gains for our use case, but I know this is not a common policy, like could be used widely in other scenarios. So that's why we make it optional. The second thing is the difference between our proposal and the CPU's distributed CPU across NUMA. I think yeah, as I said, there's a difference. What we like to control is more on the physical core side. We don't care like is on the same NUMA or different NUMA. And yeah, I think if we think we want to more like information about our proposed like options, we can also try like across NUMA and do some like performance comparisons later. From the allocation strategy, I do see the difference, but from the like performance side, currently we don't have this like data yet.
Hey, hello. Thank you for the proposal. I would just like to add that in general, adding this feature as static policy option is feasible. I think is something we can look into. But my comments, Francesco, were more about okay, let's try. I would like to see if we can implement this option, this allocation strategy as a composition or building upon existing building blocks we have, and then maybe fill the gaps or tune if we can. So build on top of the existing bits and pieces we have already, and then we can see which behavior we lack and how to address that.
Yeah, that sounds good.
Yeah, I have another Uber question. Is did you find it in testing? Did you how did you discover it? You probably have a lot of knowledge, but I'm curious how our customers will discover similar things, like how people will recognize that one policy is advantageous comparing to other policy. Do you have any insights that you can share?
Yeah, I can share that. So previously, we only turn on the static policy for doing the testing, and we found that like if you can look at the maybe the appendix. Right. So so previously like we found like when we turn on the default CPU static policy, so it will like assign the DB container to, for example, the same core with different hyperthreads. So at that time, like when we have like for example, when we have one hyperthread, like the DB container, it's like we only assign it to one one CPU. So the performance is it's like that. And then we assign it like 2 threads. So these 2 threads will be shared in the same physical core. So it's not like linearly improved for the performance. And we do more testing. And then and we found like there could be some like a noisy neighbor issue. And we actually during that time, one of my team members, one of our team members, they consult to some, I think the maybe hardware or expertise, like, and then they found like it's actually, for example, if the DB container is maybe there are 2 threads, if they bound to the same physical core with 2 different hyperthreads. So in that case, there will be maybe something like a cache contention, like there is L1 cache. It can be it actually shared by 2 different hyperthreads. So in that case, like the performance can like it's worse than if we assign these 2 different CPUs to different physical cores. So we do more testing. We found out okay, actually that's the trend, that's the issue. So we actually it's actually a different team. They conducted the experiments and they actually require like submit some requirements to our Kubernetes team and saying maybe this CPU policy may be better. Like we need to spread all the DB container into different physical cores, because at that time, like one machine typically is like most of CPUs are idle. So we only have maybe a 1 DB container running in that machine. So in that case, we need to spread the DB container into different physical cores, so we have better performance. So yeah, that's the I think the initial maybe request for this feature for this new CPU policy.
Thank you.
So in your experiments, you had only one in the database instance running, multi-threaded applications, but single instance.
So I'm not sure about the details. I only know like because we work on different teams, and they actually, so from their statement is actually for the for example, there is one physical machine. So most of the physical cores actually are idle.
No, yeah, what I'm referring to, if you scroll down to the test results.
Oh, you mean the experiments? Yeah, that for the experiments
inside the
one.
So it's database like single container pinned differently, and the rest is empty of machine.
Right, yes. For that one.
Yeah, when all those results can be easily explained.
Yeah. So, yeah, I can give some comments. They definitely have some assumption for this policy. From our online statics, what we observe is we don't see all the instances are always busy. So there's always like some instances are busy and some instances are kind of idle. So if a DB instance it is busy and the hyperthread allocate to the same like physical core that have the issue, but it does have a chance like in our case I would say a lot of chances this instance are busy. Okay, it used like the cache more than other instances that also share the CPUs. So that's our assumption because we are doing the like serverless DB instances. We don't see all the instances are busy. Yeah, that's I would claim that's like assumption for this use case now.
Yeah, I wonder if same results can be got with the same static policy, but twice a request.
Well, if CPUs are allocated exclusively and twice per request, you will get some performance boost definitely, but it's still not mitigating the issue when we're like two threads of the same application become a noisy neighbor to each other on the same physical core.
Okay.
So here are all the experiment results as I see. We all assuming what you have a very active thread of application which consumes almost the whole like physical computation power of physical core, and you have a separate hyperthread which might be like less utilized by our workloads, so it will not that much interfere with database. This is how I read the results.
Yeah, that's true. Yeah.
Okay, do we want to switch to the next topic? I think you have 3 more, right?
Sure, yeah. So the second one is the kind of maybe related to the first one. So when we have this, the new static policy, so we also need to needed to work with the in-place VPA, and we found that actually in community this is not supported, but we actually kind of need both features to work together. So we just for this one, like we proposed some solution to fix this issue to make in-place VPA and CPU manager work together correctly. Yeah, so in the solution part, I think we have several fixes for these two features to work together.
Yeah, I think Sasha summarized that comment very well about why it wasn't implemented. It's not a straightforward decision. Is your suggestion just to make it so you don't want to restart your workload, right? So you want to update in place without restart.
Right. Yes. So actually, in our environment, we already turn on these two features, and we also conducted several experiments, and also some stress tests. So right now there isn't any other issue we identified. So I think. Do we need to talk about the detailed fixes?
Yeah, it would be nice to address Sasha's comment. I just wanted to highlight the fact that when we designed VPA, we explicitly said that whether workload will be restarted or not, it's not a you cannot enforce that. You can just ask to restart explicitly, but you cannot ask not to restart. And I see more and more scenarios and use cases when there is an assumption that VPA, in-place VPA is assuming no restarts. I think if we have more and more requests like that, we probably need to deal with that and make sure that our API is allowing this assumption. So we should be able to say like this in-place VPA, like specific API, maybe explicit option we can pass or something like that, that will guarantee no restart. Because I mean, as I said, right now as designed, VPA does not guarantee no restarts.
Well, the bigger problem is actually implicit QoS. So the change might well calculate the port into different class. Right now, if I remember correctly, it's well, it's kind of fused inside VPA, so it doesn't allow what to do. But the risk still exists.
So your concern on the QS is I think you assume like a user could change any like value of the resources.
My concern is what CPU manager policies are working only with guaranteed QoS classes.
Right.
And the behavior for guaranteed QoS classes, like historically, it's maintained what, like if we give some resources to the container, we are not changing it. Or let's say we should not disappear. And in terms of CPUs, it means what we are allocating exclusive CPU for guaranteed QoS classes if the CPU manager is active. And some of the applications, let's say like the telco, DPDK-based applications, they rely on that behavior. So they like pin themselves data processing threads to those exclusively allocated cores. And if inside policy during the scaling you start to add or remove something from CPU set, you will break those applications.
Right. I think there's two things. The first thing is we want to make sure the QoS class won't be changed, and I think that's for sure because we so here we talk about like CPU manager and the in-place VPA. So the assumption is that people always choose the integer values, and they won't go back and forth between like some different QoS classes. That's I think in our case that's an assumption. The second problem is I think how application adapts to the new changes of the like CPU changes or memory changes. So yeah, I agree. That's a problem actually to application, because even sometimes we do allocate more resources or like to applications. The applications cannot detect the resource change and adapt to its like behavior. I think that's more on the application side. If the application can dynamically detect the changes, then the feature works. Otherwise, it doesn't make sense, as you said, some like DPDK or some other applications. Yeah, I would say, do we think it's better to like enable the like capabilities from the resource layer first? And then I think it's the application's responsibility to adapt to like these kind of new changes. At least we can unlock some of the applications to leverage this feature. Yeah, that's something we are thinking. Yeah.
In general, we try to prevent people shooting themselves in the foot. So if we can make it clearer and like more explicit what will happen, we will do that. So we don't fully rely on application to behave properly.
Okay.
So just speaking out of really theoretically, like imagine we enable this functionality in CPU manager, and imagine we have like preventing QoS change. So the policy should be then able to track, like when we're scaling up or down the pod, or well, actually container, VPA should know what was the original request. So we never go lower when there was original allocation. And the same goes with CPU core. So if we allocated at the start of a container some CPUs, those should be kept intact. Like we can add something and we can remove what we added later, but we shouldn't ever touch the ones which was allocated at the start. This way, theoretically, it will not break applications, but I see what it might create some other problems.
I think in the end of the day, one way or another, in-place update needs to support topology manager. So like it will I mean, some solution needs to happen, and I'm afraid that solution may be, I mean, solutions that will not rely on application to behave correctly will be to restart everything. And in some cases, even whole pod if policy was per pod allocation. So you need to readmit the entire pod and restart all the containers, which is far from ideal. So this is like one side of a spectrum is to restart everything, like entire pod needs to be rescheduled in the same node. And another side of spectrum is just do whatever requested and hope that application reacts correctly. So I think we need to find a balance in the middle. And I haven't read the solution proposal in details, but I think what Sasha brings as a concerns is a very valid concerns, and we need to decide where we want to be on the spectrum between like restart everything and just rely on application to behave correctly.
Did we ever discuss having some kind of a hook or signal to the application so it can detect and like the SIG hub, right? Like read configuration, something like that could work, or a custom hook or script that the application can add, which then gets called and it knows something changed. I need to reread the configuration and update my resources.
In upstream Kubernetes, I don't think we have anything like that.
I think we discussed it in the past.
So when we discussed the API for VPA, the API options was restart container explicitly and prefer not to restart. There are two options right now. And one of the options we discussed is exactly that, like send some signal to the container. I mean, we discussed it briefly, but we never implemented anything like that. Do you think it will help in this situation?
It depends on what kind of applications we're talking about, and depends is the application have a possibility to say no to a decision. So example with the PDK application, you're saying, you're sending signal saying, I want to remove CPU core number 5. And application should say like, no, I'm already like using it very actively.
Right, thank you.
So we had experience with that in NRI. We have a downward API as a file, which which provides a list of CPU cores which is available for application, and like using I95 watcher on this file, you can detect what something is changing, but it's like post factum, so you cannot prevent policy to change for allocations.
I think if I will summarize this item, we definitely need to work on that, and some work will be needed. If you want to move it forward, please do. I think this may be a good starting point, but make sure you read the comments and try to address as much concerns as possible.
Let's go to the next one. Yeah, this is the third one is the in-place VPA performance improvement. So we found that I think for right now for Kubernetes 1.27, the problem still exists. So if we change the resources, it will take about 1 minute to finish, like from proposed to in progress and now. For example, we need to scale up or down to the specific containers. So we actually identify the issue is like actually there are for this performance fix, we have several fixes about this one. So it's actually I think this is the first one, and can you go to the second and the third? Oh, sorry, I forgot to paste the original one. So actually in the Kubernetes SIG pod, I think the SIG pod is like a one loop to reconcile the scale resource changes, right? So at the I think at the end, actually we need to get the resource from the container CRI to know actually the resource has been like actually, for example, allocated or scaled down up. It's actually already complete. But at that time, actually, right now in SIG pod, there is no detection of that. Like we haven't get any pod status from CRI. So that's why there is like it needs 1 minute to complete the scale up and down. So we actually fixed that, like we directly get these pod status from CRI, and then we know actually in this one sync pod, the VPA has complete. Maybe it will take less than one second. So after we fix that, we found another issues actually in here is like fix 1 and fix 2. So it's all related to the pod status from API server and also the CRI being inconsistent in the code. So we fix those issues. Yeah, I will paste the original like performance fix here after the meeting.
Yeah, I don't know about specifics here. I think we will have David maybe able to comment right away, but I don't bet on that. Yeah, please send a hot fixes like fixes PR and make sure there is a description, ideally test for that. I have a bigger piece of feedback from Clayton that most of the code that was written may need to be rewritten because there are many possibilities for races. So there are suggestions how to refactor things. If it's very targeted updates while features still in alpha and it doesn't affect any other logic, definitely like let's make it better so people can test how VPA works in ideal scenario rather than like less ideal. Thank you.
Yeah, plus one on that, please. I'll review the document. It makes sense to send to Vinay as well, and we can start sending up PRs for the individual fixes.
And actually probably describe a problem statement as an issue in the official repository and tag Vinay for that.
Okay, sure. Yeah. So we can go to the last one. So yeah, this one is also related to in-place VPA. We found like sometimes it will be stuck in the progress because sometimes we do have like a customer resources in resource allocated this keyword. So I think maybe you guys already know that because in the pod, their pod has a spec and also status, right? So for the in-place VPA, we only focus on the CPU and the memory, scale up and down. So if there is another, for example, another keyword here, for example, maybe IP or GPU or network, blah, blah, some other devices in this resource allocated, then it will, for this one, the VPA will be stuck in progress because you can see the code here. So it will compare actually the resource, I think from the spec and also the status. It will never, this resource will never be equal because in-place VPA will only have CPU and memory. But for the spec, it's actually have another customer resources. So yeah, that's the issue we found, and we also fixed this one.
That's great.
But
I'm
what's
really
actually
excited that somebody. Oh, go ahead.
It's actually the same triggers the question about restart, not restart. So everything what we are not restarting, we need to have a comparison what its native resources. For everything else, if we have changes, we need to force restart containers to trigger the allocation of those resources, like device plugins or anything else, or extended resources. So it might be a bigger issue here.
That's a good point, Alex. So sounds like number 4 is the bug. Number 3 is enhancement optimization. Number 1 to 2, we need to continue to discuss more.
Yeah, I'm so excited that you're trying it out and giving feedback. This is a big feature. Everybody wants to start using it, but I'm a little conscious about it. Like so many issues. Like whenever somebody tried it, they found something to report. We have over 20 bugs reported in Kubernetes issues list just for this feature.
Great. Do you have a like issue list? Do we have a tag for this issue to easily find those 20 problems? So we probably can check and see whether we can match our fixes with those issues. So we can reference those issues if we fail the like PR.
Yeah, I have a list all this issue. Yeah.
Oh, great. Yeah. If
Do we want to
can
discuss it right now or?
Oh, Zoe. Okay. Yeah, I think probably later. Yeah, we can do it.
Okay, gotcha.
Later. Yeah.
Okay.
Okay, great.
Yeah, one idea would be to pause this list on enhancement issue. So we have some summary of what will be happening, and it will tackle most of the problem in 129. It will be a great improvement.
Mhm.
Okay, let's go back to the agenda. Is there anything else? If not, then thank you, everybody. Have a great rest of the day. Bye.
Yeah.
Thanks.
Bye.
Thanks for this